Francis Bacon, who you can see here pictured, is known as the father of science. Bacon lived in England and during his lifetime held high political office as Attorney General and Lord Chancellor. But it's from his accomplishments in science that his reputation today derives. In fact, Bacon's devotion to science was so great that one account of his death has him catching a fatal bout of pneumonia while doing an experiment on the effects of freezing on preserving of meat in snow. If this story is true, then it's somewhat appropriate, since while Bacon did make contributions to scientific knowledge, for example in his book History of Life and Death, it's for his contributions to the method of doing science, and in particular to introducing experiments as an important way of doing science, that Bacon's most known. Joel McKeer has described the Baconian scientific program as consisting of three elements. First of all, an attempt to expand humanity's knowledge of the natural world using inductive and particularly experimental methods. Secondly, directing research towards areas where practical problems could be solved. And thirdly, making access to costs of knowledge as low as possible by the methods of organising knowledge that were used and by disseminating knowledge. Bacon was part of an important period in Europe in the 16th and 17th century known as the Scientific Revolution. In this period there were major advances both in scientific knowledge and in methods of doing science. Lisa Jardine, a historian of science, has written of this period that its breakthroughs in thought and its advances in science still stand today at the centre of modern life. There were three main elements to the scientific revolution. First of all, advances in scientific knowledge. Secondly, advances in scientific methodology. And thirdly, advances in dissemination of scientific knowledge. With regard to the first of those factors, advances in scientific knowledge, during this period there are major advances in fields such as astronomy, anatomy, mechanics and physics. The main contributor was Sir Isaac Newton, but there was a huge cast of interesting supporting characters, many of whom are discussed engagingly in Lisa Jardine's book, Ingenious Pursuits. Two of my favourites are the experimentalist Robert Boyle and the scientific instrument maker Robert Hooke, who are shown here with a scientific instrument that's known as an air pump, which was basically a device from which air could be extracted, creating a vacuum inside it. Jardine has talked about the experiment they did with a man-sized air pump and what happened with that. So she says, Hooke's bravura as an experimentalist, his pure showmanship stood the Royal Society in excellent stead over the years. If need be, he was prepared to experiment on himself. On one occasion in 1671, he devised a man-sized chamber for the air pump and volunteered to occupy it while it was evacuated. Fortunately for Hooke, the pump performed middlingly, emptying only about a quarter of the air from the container. The sensations he reported when he came out of his airless container were giddiness, deafness and pains in the ears. The second main element of the scientific revolution was a new method of doing science. Before the scientific revolution, there were really four ways of getting or sourcing knowledge. There was tradition, there was religion, there was logic, and there was observation. What Bacon did was to introduce a fifth method of doing science, or a fifth way of supporting or sourcing knowledge, which is the experimental method. As Jack Goldstein says, there was a new way of knowing, programs of experiments with instruments and scientific apparatus. The third aspect of the scientific revolution was increased access to scientific knowledge, and there was a variety of reasons and ways in which this occurred during this period. First of all, there had been improvements to the storage and transmission of information. For example, writing and printing had made it much easier to store, in the case of writing or printing books, and to transmit that knowledge to a broad audience. Secondly, scientific knowledge came to be a public good. Public good in the sense that it could be drawn on by a broader group in the population than had previously been the case. And one way in which that happened was that common languages for conveying ideas were formulated. For example, mathematics became increasingly adopted as a language for describing scientific ideas, so that anyone who understood mathematics then was able to gain access to the ideas through that language. Thirdly, there was an emergence of points of contact between scientists and, for example, craftspeople. So there were coffee houses where scientific discussion occurred, and there were the academies, which were basically devoted to presentation of experiments, presentation of new knowledge about science. The scientific revolution was part of a broader social phenomenon known as the Enlightenment, which occurred in Europe in the 17th and 18th centuries. The Enlightenment had as its objective was an intellectual movement that had as its objective to make reason supreme, to apply reason to discover new knowledge that could be applied to improve the functioning of society. And so this encompassed the scientific revolution, but it was also broader than that. It was extended to the economy, to government, to religion. So to sort of all of the spheres of society, the idea was to apply reason to discover new knowledge in those areas. In England, one of the most notable Enlightenment thinkers was Adam Smith. In his Wealth of Nations, published in 1766, Smith set out to discover universal laws about the operation of the economy. And from those universal laws, he derived proposals for the way in which economic activity could be best organised to maximise human well-being. In particular, Smith emphasised what he believed was the superiority of allowing the invisible hand of the market to organise as a way of regulating or organising economic activity, rather than allowing government regulation. In France, the great Enlightenment document was the French Encyclopedia, a work of 28 volumes that drew on entries from nearly 200 authors. The objective of the encyclopedia was to bring together a wide range of useful information and to disseminate that information to as wide an audience as possible. So one important thing about the encyclopedia was this idea of disseminating useful information. The other really important principle in the encyclopedia was the thoroughgoing application of reason in the encyclopedia entries. And John Hirst, the historian John Hirst, has nicely summarised this by saying that the French encyclopedia was not, as we think of encyclopedias today, a state authority written by established scholars. This was a radical encyclopedia because it applied reason to everything, and it gave no hierarchy within knowledge. For example, it didn't start, as the church would have liked, with theology and God. So the Enlightenment was important social movement, intellectual and social movement in Europe in the 17th and 18th centuries. It didn't change European society in an instant, but it did have a gradually growing influence that throughout the period increasingly affected the way intellectual activity was done and affected organisations such as government and the church. In the next lecture on the Industrial Revolution, we'll see how the scientific revolution and the Enlightenment also influenced that major development in the history of the economy. In the next section of this lecture, I'm going to go on to talk about what was happening specifically in England before the Industrial Revolution.